In today's material, I will solve with you such an equation. X under 3 plus 9 under x equals 4. This is a type of equation that combines two things: a common fraction and an expression with an unknown in the denominator. You can compare them, try to transform them in different ways. Multiply by a common denominator, try to reduce to a common denominator, and sometimes even replace something with an auxiliary variable. But let's not get ahead of ourselves. I will show you exactly step by step how I approach it and why I choose this method. So let's look at this task. Here we have two fractions and some number. However, this number could also be written as a fraction. So in total, we have here in this task fractions, and we have addition. So to add fractions, we would need a common denominator. So we could reduce to a common denominator. I, however, would like to get rid of all these denominators and write this equation as a sum of monomials. So to do this, you need to find the least common multiple. The least common multiple in this case of this task is quite easy to notice, because if we multiply each of these denominators, that is 3 multiplied by x and multiplied by 1, we will get 3x. So to solve it correctly, you have to start by multiplying both sides by 3x. We multiply. If we multiply by 3x, then 3x appears in the numerator of each of these expressions. I will show you what it looks like. 3x multiplied by 3 plus 3x multiplied by 9 divided by x equals 4 multiplied by 3x divided by 1. Here, I changed the order, which does not matter in the case of multiplication. We can reduce these fractions. For example, here 3 with 3 by 3. We can reduce here x by x, and here we cannot reduce anything. Let's write down the results. We have x squared plus 3 multiplied by 9, which is 27. Equals 12x. Let's move on. We will transform this equation in such a way that we subtract 12x from both sides, so that there is 0 on this side, and to make it easier for us to solve. At the same time, we will transform it in such a way that this number will be in second place just behind x, which is x squared minus 12x plus 27. And this is equal to 0 because we subtracted 12x here and it was reduced. Now we have such a task. I will use here the so-called factorization. I will not calculate the quadratic discriminant, that is the delta. I will just check what product gives me 27. And then I will add these numbers and check if I got minus 12. I looked at this number, and first of all, I noticed that there is a minus here. So I will look for the product of two negative numbers, so that the sum also gives a negative number. I assume that it will be minus 3 multiplied by minus 9. If we add this number, swap sign of the operation, we will get minus 12, and it is right. So let's write it this way. However, it is worth remembering that the form of the quadratic function in this one that looks like this is the product form. And in the algebraic formula, it looks like this. Firstly, in short thinking, it means that each zero place is hidden here with the opposite sign. That is if it is written x minus 3. Zero place, or simply the answer to our question, is the result. 3 here, analogously 9. But it is, as I mentioned, short thinking. Firstly, we already have the result, but secondly, we can prove these calculations how to do it. When we have such an equation written down, we notice that here there are two brackets, and between them there is a multiplication. These two brackets are multiplied. That is this expression times this expression. If we look closely, this product is equal to 0. And what numbers that are multiplied with each other will give 0? For example, 0 and 5, for example, 0 and 7, for example, 0 and minus 3. Any multiplication with 0 will give us a number equal to 0 when we multiply them. So we have to assume that either this bracket is equal to 0 or this bracket is equal to 0. So let's calculate x minus 3 equals 0. Let's add 3 on both sides. And we have our result, the first one. Let's equate the second bracket to 0 because we suspect that it can also be equal to 0. On both sides, let's add 9, and the result, then we get 9. And we have our second solution. And these are the correct solutions. If that's what you had at the very beginning of this task, here, as soon as the operation appeared, then yes. You are right, but maybe you don't believe it? Let's try to rewrite it. Now a moment, hop. Let's stick here and so-called check-in. Place of the x's, we will put the numbers that were there a moment ago. 3 under 3 plus 9 under 3, 3 under 3 is reduced by 3. This is 1. 9 and 3 is also reduced by 3. This is 3. This is 1. So 1 plus 3 equals 4. This is the correct answer. This is a little bird. Oh. It is correct. Let's try to insert now, since we put a 3 in place of x. Let's put a 9 divided by 3 plus 3 divided by 3. Sorry, 9 divided by 9. Equals. Let's reduce this time here by 3. And here by 9, this time we have 3 plus 1, which is also 4. And proves that we were right. So we have correctly solved the task. We have a check. So we can proceed to the last part of the video, that is the ending. Thanks a lot for watching this episode. I hope it was helpful for you and that this task gave you some satisfaction or at least puzzles. If you want more such materials, remember to thumbs up, subscribe, and click the bell. And if you want me to help you personally in your studies, click support under the video and see what level of support suits you best.